Hello everyone, welcome to our channel One Shot EAMCET. This is the day 1 of our 40-day AP EAMCET 2025 Crash Course. Today we are starting with quadratic equations, which is a high weightage topic in mathematics. In today's video, we will learn about standard form of quadratic equations, roots and discriminant, nature of roots, and at the end some word problems and previous year questions. So let's dive in. A quadratic equation is any equation of the form ax square plus bx plus c equal to 0 where a is not equal to 0. For example, 2x square minus 5x plus 3 equal to 0 is a quadratic equation, but 3x plus 2 equal to 0 is not a quadratic equation because the x square component a is 0 in the term 3x plus 2 equal to 0. So in general, a standard form of a quadratic equation is determined by ax square plus bx plus c equal to 0, where we say a is not equal to 0, b and c are some real numbers. So let's move on. So in order to find the roots of the quadratic equation, there are three methods. Number one, we have factorization, which is called splitting the middle term. And number two is quadratic formula. And number three, we completing the square. So let's start with the first method using factorization. So let's solve the quadratic equation x square minus 5x plus 6 equal to 0 using factorization. So in factorization, we are splitting the middle term. So in our case, the middle term is minus 5. So minus 5, if we want to split, we can split into minus 2 and minus 3, which implies the equation is now x square minus 2x minus 3x plus 6 equal to 0. So to simplify this, we have written in x into x minus 2 minus 3 into x minus 2 equal to 0. It further implies x minus 2 into x minus 3 equal to 0. So if we solve this, it is clear that therefore x equal to 2 or x equal to 3 are the two roots of the quadratic equation x square minus 5x plus 6 equal to 0. If you have any doubts, please post it in the comments. Now let's solve the same equation using the quadratic formula. So we write the equation x square minus 5x plus 6 equal to 0. And here, as a step 1, we identify the coefficients. So the coefficients we write with, so we compare with the standard form, which is ax square plus bx plus c equal to 0. So for our equation, a is equal to 1, b is equal to minus 5 and c is equal to 6. So in step 2, we write the standard quadratic formula. The roots of a quadratic equation are given by x equal to minus b plus or minus square root of b square minus 4ac by 2a. So here there is a discriminant called d. The discriminant is nothing but b square minus 4ac. So now we substitute the values of a, b and c, and here we write b square, which is minus 5 whole square minus 4ac, 4 into 1 into 6. So minus 5 whole square is nothing but 25, and 4 into 1 into 6 is 24. So 24 minus 25 minus 24 is equal to 1. Since d is greater than 0, the equation has two distinct real roots. Now we substitute these into the quadratic formula, right? So x equal to minus of b, which is minus 5. So minus of minus 5 plus or minus root d. D is nothing but b square minus 4ac. So we got d as 1 in our previous step. So here we got d as 1. So we substitute the value of d in the square root. The square root of 1 is nothing but 1 again. So we have minus into minus 5 is 5 plus or minus 1 by 2 into 1. So 2a is 2 into a is 1. So 5 plus or minus 1 by 2. So in the final step we have the roots as first root is positive root, which is x equal to 5 plus 1 by 2, which is 6 by 2, that is 3. So x equal to 3 is first root, and the second root where we put minus. So x equal to 5 minus 1 by 2, which is 4 by 2, and x equal to 2. The final answer is x equal to 2 or x equal to 3 are the two roots which we found out using the quadratic formula. Okay, now let's talk about discriminant and the roots of nature of roots. The discriminant d tells us the nature of roots, like we saw earlier. Whenever the d is greater than 0, the roots of the quadratic equation are real and distinct, like how we saw in the earlier example. Here the d is greater than 0, hence we have two distinct real roots. So one root is x equal to 2 and the other root is x equal to 3. Now the second thing is, if d equal to 0, then the roots are real and equal, which means both the roots are same, like it has one and only solution. That means if x equal to 2, then the other root is also x equal to 2, or if x is 3, then other root also will be x is 3. So that's where d is equal to 0. It implies that the roots are real and equal. Now the third case is d is less than 0, which means d is in a negative value. At that time the roots become imaginary, because we have to find the square root of d at some point, and when we go for square root of d where d is a negative value, then it becomes a complex number and the roots become imaginary numbers. So there the complex numbers come into picture. Now let's take an example again. Let's take 3x square plus 6x plus 2 equal to 0 and find d. Now discriminant formula is simple. D is equal to b square minus 4ac. Now here for the equation 3x square plus 6x plus 2, we have a, b and c as 3, 6 and 2. So simply we put b square, which is 6 square, and 4 into a into c, 4 into 3 into 2. So 36 minus 24, which comes to 12. Here again the d is greater than 0, so the roots are real and distinct. We can solve it using the previous example again. Now let's look at the other two examples of how the roots can be equal. Let's take x square minus 6x plus 9 equal to 0 and solve it using the quadratic formula. Here we take the coefficients a equal to 1, b equal to minus 6 and c equal to 9. To find the discriminant, we put the formula again, d equal to b square minus 4ac. So b square is nothing but minus 6 whole square and minus 4ac, 4 into 1 into 9. So it is 36 minus 36, which comes to 0. Now as per the nature of roots, we learned that if d equal to 0, the roots are real and equal. So equal means repeated roots, because d equal to 0. Now to find the roots, we put x equal to minus b plus or minus root d. So square root of d is 0 always, because d is always 0. So d, whenever d is 0, the square root of d will also be 0. So it does not matter whether the plus or minus is different, because after the plus or minus it's always 0. So now we substitute the values. It is 6. So minus of minus 6 is 6, because b root minus b. So 6 plus or minus 0 by 2, which means both the answers are 3. So 3 is the only one unique solutions for the equation x square minus 6x plus 9 equal to 0. Clear? If you have any doubts, please write in the comments. Now let's go to the third example. Let's solve 2x square minus 4x plus 5 equal to 0. So here the coefficients are a equal to 2, b equal to minus 4 and c equal to 5. Here the discriminant is minus of b square, which is minus 4 whole square, minus 4 into 2 into 5. So 16 minus 40 is minus 24. Now the nature of roots here is imaginary, which means complex roots, because d is less than 0, right? So if you put that in the formula again, here you can see that the square root of d will come in a square root of negative value. So we have to introduce the term I for complex numbers. So now the roots of x are nothing but x equal to minus of minus b, which is 4, plus or minus square root of minus 24. So to find the square root of minus 24, we have to introduce 2i and square root of 6, because I is minus 1, square root of minus 1. So now 4 plus or minus 2i square root 6 by 4, which is, if we simplify the roots, it comes to x equal to 1 plus root 6 by 2i, and the other root is x is equal to 1 minus root 6 by 2i. These are the two solutions of a quadratic equation 2x square minus 4x plus 5 equal to 0, where d is coming to be a negative value. So both the roots are complex in nature, and if you have any doubts, you can ask in the comments here. Let's look at some word problems. Here the question is given in a word form. You have to find the equation of it. Okay, so in order to do that, the concept is, we know sum is equal to minus b by a and product equal to c by a. So if we have a given problem where it says if the sum of roots is 5 and the product is 6, then find the equation. So we simply put the sum equal to 5 and product equal to 6. Then we substitute the values of b, a and c. So sum equal to minus b by a. So minus b by a is nothing but 5. So the b value comes to be minus 5. So we substitute here and the equation comes to be x square minus 5x plus 6 equal to 0. That is how we substitute for any word problem in the question. Now the standard formula you have to remember is, for ax square plus bx plus c equal to 0, the sum of alpha plus beta is equal to minus b by a, where alpha and beta are the roots of the quadratic equation. Now since the in this example, if we see the sum of the roots is 5 and product is 6, so we substituted the sum and product directly, where alpha and beta are the roots of the equation. We don't have to find the roots of the equation, but we have to compose the equation using this formula. A product of alpha and beta is C by A. Now let's look at a previous year question of 2023 EAMCET. Okay, so this question says if roots of x square minus kx plus 4 equal to 0 are equal. So here he doesn't give us the roots directly, but he says d equal to 0, the because both the roots are equal, and he wants us to find k. K is nothing but the value of which is not given here, but the value of d we can find because the roots are equal. So d equal to 0. So now we substitute the formula here, d equal to b square minus 4ac equal to 0. Now we know that a equal to 1 and b equal to minus of k, because k is what we are trying to find here, and c is clearly 4. Now we directly substitute d equal to b square minus 4ac, which is minus k whole square minus 4 into 1 into 4. So k square minus 16 equal to 0 and k square equal to 16. So k is equal to 4 or minus 4. So there are two values for k, which can be either 4 or minus 4. So that's how we solve this. Let's recap what we have learned so far. Okay, we learned that the quadratic form is ax square plus bx plus c equal to 0. And to find the roots using the quadratic formula, we have x equal to minus b of plus or minus root d by 2a. And to find the nature of roots, we have the discriminant equal to b square minus 4ac. So your exercise for today is solve these two equations. 2x square plus 5x minus 3 equal to 0. Find the roots of it. And the second one is like, if the sum equal to 4 and product equal to minus 4, find the equation of this. Okay, that's all for today, guys. Thank you, and we'll catch up in the next video.